Yeah, I think you people know aware about this maybe. Okay, so here you have to create your account and you have to go through the modules. Okay, you can just create account and like there are 4 modules are there, maybe object oriented OOPS concepts, then Python module is there, and database concepts. And these modules are no like it will be helpful for all company, all placement. Okay, not only in Infosys. Okay, not only in Infosys, in all company, all and that is video based learning is there, like videos and some like you people have to do some tasks. Okay, so you people do it, that will be benefit for you. Okay, this one in InfinityQ, I think you people are having account for this maybe. Okay, so means all the contents are available there, so you just need to practice. Okay, so as we discussed yesterday about the pipelining technique. Okay, so in the pipelining, uh, what are the main points we discussed in the pipeline process? Okay, so here the time required to complete the task or the time required to execute the instruction is same. Okay, here there will be no change. Okay, but with pipelining, what is the advantage with pipelining technique? The throughput will increase. Throughput or the speed execution, it increases. Okay, and yesterday I have discussed like this will be increased in the case where the time required for each like stage. Okay, the time required for execution of instruction, time required for the execution of instruction or the stage, if it is same. Okay, if like 1 clock cycle or 2 clock cycle, if it is same for each stage, then uh, we won't find any delay, so the speed up or throughput will increase. But if there is any delay in the availability of instructions or availability of the operands, ऐसा कुछ डिले हुआ during the instruction execution, during the instruction execution. Okay, if there is any delay, then the throughput will decreases. Okay, the performance or the throughput will affect. Okay, so that we can in terms of pipelining, it is called as hazards. Okay, it is called as hazards. Okay, so here the performance improvement is achieved only if the operation is sustained. Operation is sustained without interruption. Okay, operation is sustained without any interruption, means without any delay in the availability of the data and all. Okay, so if the instruction execution or the operation, okay, instruction execution or operation, okay, if there is this operation will be done without any delay or interruption, then the performance will be improved. So but the operation in pipeline is very complex. Okay, the operation in the pipeline, this is very complex and hence prone to errors. Means like yesterday we discussed the pipeline means like here like this is the suppose 4 stage, then the second instruction will like here means at a time the parallel operation will perform. Okay, so this is the first instruction, second, third and fourth instruction. So here means suppose here 1 2 3 4, in the fourth clock cycle you can observe all these 4 instructions are at different stages. Okay, means it is a, here we are consider here only 4 instruction, but normally while executing the, if there are thousands of instructions will execute at a time, millions of instructions execution at a time. Okay, then okay so that's why this pipelining, it is a very complex process. The execution of instruction or operation in the pipeline is very complex and hence prone to errors. So this, the problem that occur in the pipeline which affect the performance is called as, it is called as hazards. Whatever the problems that occur, okay, in a pipeline, that is called as hazards. Okay, so the potential increase in the performance resulting from pipeline is proportional to the number of pipeline stages. So the performance it is depend upon the number of pipeline stages. As in the yesterday we discussed, like 2-stage pipeline, 4-stage pipeline, 5-stage pipeline. Means to execute one instruction, it will pass through all the phases, all the stages. Okay, 1 2 3 4 here, 1 2 3 4 5. So this is here the input, the instruction execution is started, and it will pass through these stages. Okay, there are how many stages are there? 5 stages. So this is a 5-stage pipeline, 5-stage pipeline, right? 5-stage pipeline. So unfortunately what happens, no, like however, this increase would be achieved only if all pipeline stages, they require the same time to complete. Means one clock cycle, this is also one clock cycle, one clock cycle. Means if the performance will be increased if all these stages, if it is supposed to take one clock cycle, but unfortunately it is not happened. Okay, there is no interruption throughout the program. Means if it is same time for each stage, same clock cycle, same clock cycle. Okay, then there is no interruption throughout the program execution. But unfortunately it is not true. Means there will be some interruption occurs. Okay, so pipeline hazards, what are the different type of hazards? So yesterday we discussed about this. There are 3 type of hazards. So one is a data hazard. As the name indicates, data means the operands are, it deals with the operands. Okay, data hazard means any condition in which either the source or destination operand of an instructions are not available at the expected in the pipeline. Okay, means like if the instruction is fetching some instruction, okay, like for example a add b. Okay, so suppose this 8085 instruction add b, what happens here? It adds content of b plus content of a register and store the result in a register, right? So while fetching the data, Here, if suppose this data is not available, content of A or content of B, then some delay will occur. Okay, so here the data hazard any condition in which either the source or destination operands of an instructions are not available at the time expected in the pipeline. So some operation has delayed. Some operation has to be delayed because data is not available. Then pipeline stall will occur. Pipeline stall. Pipeline stall means here there is a delay in the execution of a instruction. Then comes the instruction hazard. Okay, so in the instruction hazard, a delay in the availability of an instruction that causes the pipeline to stall. Means while fetching the instruction, so there is some delay. There is a delay. Okay, the next instruction is not available. Okay, if there is some delay, then that is called an instruction or control hazard. The name is same, instruction or control hazard. Okay, then structure hazard will come. Structure hazard, the situation when two instructions require the use of given hardware resources at the same time. Okay, structural hazard means the use of given hardware resource at the same time. Okay, means for example, okay, so here which one is and which hazard, that is structured hazard. Structured hazard. So structured hazard means suppose like this is the instruction fetch, decode, execution, write back. Instruction fetch, decode, execution unit, then write back. If there is a 4-stage pipeline, okay, if there is a 4-stage pipeline, okay, fetch, decode, execute, and so here what happens in the structural hazard, okay, when two instructions require the use of given hardware resource at the same time, means for example some memory related instructions, what they do, memory related instructions, like for example load operation or store operation, load or store operation. Okay, so load also deals with load instruction, load also deals with the it related to memory. Okay, memory unit. Store operation is also related to memory unit, right? Load and store, so both are related to memory unit. So load instruction and store instruction, both load and store both are deal with the memory. So if there are two instructions, if there are first instruction and second instruction, if at a time if they want to use the memory unit, okay, if at a time this also want to use the memory and this also want to use the memory at a time, but here only one instruction can access the memory unit at a time, one has to wait. Okay, so one has to wait, so that's why, so one instruction has to wait, so because of that the delay will occur. Okay, delay will occur, so that is called a structural hazard. Structural hazard. Okay, so structural hazard means in a situation when two instructions require the use of given of hardware resource at the same time. Okay, means at a time only one they can use. Okay, so data hazard where due to the non-availability of the data, non-availability of the data, that is source operand or source operand, if it is not available, data hazard will occur. Data hazard means what? Hazard means delay. Then instruction hazard or which one? Control hazard. Okay, so this control or instruction hazard, if while fetching the instruction, if the instruction is not available, if the instruction is not available, if the instruction is not available, okay, then particular this hazard will occur. Then structural hazard. So structural hazard means the situation where if the two instructions requires to use same hardware resource, same hardware, if it is two instructions, if they want to access the same hardware resource, then some delay will occur. Okay, means at a time only one instruction can use the hardware, because if there is only one memory unit, ओके पहला लोड ऑपरेशन तो करना पड़ेगा, नहीं तो स्टोर, डिपेंड अपॉन द इंस्ट्रक्शन, उसके बाद स्टोर, because only one memory unit is there. Okay, suppose if for a house, if there is only one door and only one person can pass here, okay, only one person can pass inside the house, then so ये पर्टिकुलर डोर यूज करने के लिए एट ए टाइम वन पर्सन कैन गो, ही हैज टू वेट टिल अंदर जाने तक. ओके, so some delay will occur, some delay. Suppose ऐसे दो डोर रहा तो वो अलग बात थी, there is no need to wait. Okay, so to three type of hazards. Then this is the example for data hazards. Okay, so here you can see in the, actually the diagram is not showing here. So when we convert to, there is some error it is giving. Okay, so this is the diagram. I hope the screen is visible. Okay, so here the clock cycle is there, clock cycle 1, clock cycle 2, 3, 4, 5, 6, 7, 8, 9. 9 clock cycle is there, and here it is the instruction I1, I2, I3, I4, I5 instruction. There are 5 instructions are given. So during the clock cycle 1, the first instruction is executed. During the second clock cycle, first instruction is in the decoding stage. At the same time, the second instruction is fetched. Then third clock cycle, the first instruction is in the execution stage, second instruction is in the decoding, and third instruction is fetched. So during the clock cycle 3, first instruction is in the execution, second in decoding, third in fetching. Fourth clock cycle, write result. Okay. So here it is writing the result. Then in the second that at the same time, for the second instruction, the execution unit, okay, so execution unit means the second instruction in the execution stage, it is taking two more extra clock cycle. It is supposed to take this one only a particular clock cycle lena tha, okay, but this instruction it is executing, it is taking some more time, okay. It is supposed to complete in the fourth cycle because every instruction every all the stages take the equal amount of time, but there is some due to the some data dependency, because here execution operation is going on, like execution means that suppose add b means add content of a plus content of b, store the result in a, एक addition operation हो रहा है, and here it is taking some time to store the again the result in the a register, okay. It is taking some time. So here it is taking one cycle extra, then one more two extra cycles. It is supposed to take only one clock cycle, but दो extra clock cycles ले रहे हैं, okay. It is taking two more extra clock cycles, okay. So here why this delays occur, it is occurred because of the data dependency. This is occurred because of the data dependency, okay, because of data dependency. So here from the figure, the stage E2 of instruction I2 takes 3 clock cycles to complete. So here this particular this is taking the total 3 clock cycles. Actually it is supposed to take only one, but यहाँ क्या ले रहा है, it is taking total 3, means 2 extra ले रहा है, okay. This stage, execution stage, it is taking the 3 clock cycles to complete. Thus during the clock cycle 5 and 6, the instruction I3 and I4 cannot go to the here. ये अभी ये कुछ नहीं कर सकते because execution unit it is busy, execution stage is there, no, it is busy, so there will be a delay occur for the I3 and I4 instructions, because I3 it's in the at the end of the clock 4 the decoding stage is completed, and next is in the fifth clock cycle it is supposed to go for the execution stage, execution unit, but the execution unit it is engaged by which instruction, I2, it is engaged by the I2 instruction, okay. So some delay will occur, okay, and it has to solve because अभी ये कुछ नहीं कर सकते, the I3 instruction it cannot go to this stage. Why? Because E2 is engaged with the I2 instruction, and here I4 instruction it cannot go to the decoding stage. Why? Decoding में कौन है अभी, I3 instruction है, in the decoding I3 instruction is there, okay. So this decoding unit is not free, so that's why so I4 instruction it cannot go to the decoding stage. So here I3 and I4 cannot go to the execution stage since I2 has not yet completed the operation. Second instruction has not completed the operation. It is taking the extra clock cycles, okay. So where it is, yeah. So all instructions are delayed. Next I3, I4 instructions all are delayed, and it is said to be it is called as stalled for 2 clock cycles, means it is taking the extra 2 clock cycles, okay, extra 2 clock cycles. So that is stalled, stalled for 2 clock cycles. Okay, so a data hazard is a situation in which the pipeline is stalled because of operands are not available, because of the operands are not available, because of the operands are not available, because of the operands are not available at the time expected in the pipeline, hence some operation here delayed, hence some operations are delayed. Okay, it is stalled because the operands are not available, and that at the time of expected means yeah, actually यहाँ आना था but it is not getting. Okay, here it is supposed to complete here, it is supposed to take only 1 clock cycle, but it is taking the 2 clock cycles extra, so that is stalled for the 2 clock cycles. Okay, so it will affect the I3 instruction, I4 instruction, I5, all next instructions will be delayed. So this is called as a data dependency. So in the examination you have to write this diagram, you are supposed to write this diagram for data hazard. You have to explain what is data hazard. Okay, where the in which either source or destination operand of an instructions are not available at the time of execution. You have to write this diagram. Okay, then there is one more example for the data hazard, that is the data dependency. Because of data dependency, like for example there are to consider 2 instructions, one instruction, second instruction. Okay, so here you can observe, suppose if there is a value a value is initially suppose 3, so what is the value of b here? B is equal to 12, right? Now the new value is 12, and for second instruction c is equal to b plus 3. So see here, this is the second instruction, and the second instruction it is depend upon the first instruction. Okay, second instruction depend upon the first instruction, the b variable. Okay, so this b value, it is because yeah, see initially maybe some value b is equal to maybe 9. Okay, initially, but suppose if the a value is 3, a is 3, then b value will change to 12. Initially there may be some value, any value, 8, 9 or 0 something, any value, but once this instruction is executed, b value will be 12, right? B value is 12, b value is 12, then c is equal to it is supposed to get c is equal to 12, it is minus, no, if a is equal to 3, then b कितना होता है 12, c is supposed to come 15, then this is the correct. Okay, but here what happens, initially suppose b का value 8 है suppose initially, तो 8 will be, so once this instruction is executing, तो b का वैल्यू कितना चेंज हो जाता है 12, बिकॉज a इज इक्वल टू 3 है. ओके, एंड नेक्स्ट इंस्ट्रक्शन इज c वैल्यू इज 15. तो यहाँ कैसा है, डेटा डिपेंडेंसी है. डेटा डिपेंडेंसी मीन्स इफ यू वांट दिस करेक्ट रिजल्ट, correct result of correct value of B and C, then ये पहला instruction complete होना चाहिए. It is supposed to execute completely, because here the second instruction, the value of B is depend upon the result of first instruction. Okay, suppose if the first instruction is not executed, then this C instruction, the second instruction will take the old value. Old value कितना है? 8 है. 8 plus 3 execute होता है फिर. Will get wrong result. तो यहाँ क्या होना चाहिए? First instruction it should execute. First instruction it is supposed to execute completely. Then only we will get the value of B. Otherwise, the C instruction what it does, it will take the old value. Old value कितना है? Old value B है. So उसका result कितना आता है? 11. So it is wrong. Okay, because here it is calculating with old value. So some data dependency is there. Okay, data dependency. So another cause of data hazard is data dependency. As an example, so consider two instructions I1 and I2. So these are the two instructions. Let A is equal to 10, and if the sequence is followed, B value is 43, but if they are executed concurrently, the result will be different. Okay, the result will be different. So here the second operation depends upon the result of first operation. Okay, second means second instruction, it is depend upon the result of first. B value dependent hai, right? The value of B depend upon the first instruction. Depend upon the first instruction. Okay. So here causing the pipeline to stall for one or more clock cycles. So data dependency is the main reason for pipeline stall, and its effects must be eliminated by achieving a better performance. Okay, we have some solutions how we can avoid this dependency. Okay, so because of dependency, okay, the performance will be degraded. So data hazard here in this, there are two cases we explained. That is, one is because of dependency, because of the dependency, non-availability of source, or non-availability of source or destination operand. Source or destination operand. Non-availability of the source or destination operand. Then another case is that data dependency, right? So here yeah, the same example here you can see, observe, clock cycles are there, then instruction I1. So the same instruction here, that is a multiplication instruction, right? So here the first instruction is multiplication instruction. So here it is fetched in the first clock cycle. In the second clock cycle it is decoded, and at the same time the second instruction is fetched. Okay, during the third clock cycle, means the execution unit, okay, the multiplication operation. Okay, so means it is performing some like B is equal to A into 4. B is equal to A into 4, and C is equal to B into B plus 3. Okay, suppose. So this second instruction depend upon the first instruction. तो third clock cycle में क्या हो रहा है? The first instruction is in the execution stage. At the same time, second instruction is decoded because the decode unit is available, and the third instruction is fetched. So third is different. Okay, any instructions. Now in the fourth clock cycle, it is writing the result. Okay. So writing the result means, अभी suppose यहाँ A value, suppose if it is 10, so B is how much? 40. The B value is 40. Okay. So execution unit means it will perform the operation. Execution unit means like it will take the value of A into 4, so 40. Means it is not, it is just performing the operation, it is not writing the result. Okay, so this write result is there, no, means it is writing the result back to some register. Okay, so here here we are generally we are showing, but actually there are some hardware, the components are involved here. Okay, so to write the result into the specific register, it takes some time. Okay, for write result it take a time. Okay, and also, okay, here write result, and at the same time here in the clock cycle what happens, clock cycle, the second instruction, okay, the second instruction means, yeah, decode. So decode means what, it is supposed to decode means what is the value of fetching means fetching the instruction, so this is the second instruction. But यहाँ क्या होता है, decoding means it has to decode the value of B. So value of B is not available because at the end of the clock cycle 4 we will get a, या right result होने के बाद we will get a B value, means at the end of the third cycle suppose if it is available then we can go for the next unit. But यहाँ क्या हो रहा है, the B value we are getting at the end of the clock cycle 4 because right result, ये ऑपरेशन होने के बाद ही उसका ये जो फर्स्ट इंस्ट्रक्शन का जो रिजल्ट है that we can get. Okay, so here, तो यहाँ क्या होता है at the end of the 4 and end of the clock cycle 4. Okay, here we are getting the value of B, then it is executing that the decode operation. Okay, तो यहाँ क्या हो गया, एक एक्स्ट्रा क्लॉक साइकिल, there is a delay of extra, and here decode unit is not available, so again here delay will occur. Okay, then in the sixth clock cycle decode के बाद execution and third instruction will be in the decoding stage. So likewise here there is a delay is occurring. क्यों, क्योंकि यहाँ डिपेंडेंसी था. सपोज इफ इट इज टेकिंग, यहाँ अभी एग्जीक्यूट किया तो it has to take old value of the B. So new value of the B we are getting where, at the end of the clock cycle 4. At the end of the clock cycle 4, यहाँ आप हमको मिल रहा है, यहाँ at the end of the clock cycle 4 we are getting the value of which B register, no, B register. Okay, so then after that it is performing decoding. Okay, so that is data hazard. Then instruction hazard. Instruction hazard means a delay in the availability of an instruction. A delay in the availability of an instruction that causes the pipeline to stall. Okay, so fetch for instruction I2 that results in a cache miss. Means if the instruction is not available, so that is a cache miss. We call it as cache miss, and it is delayed till the cycle 4. Cycle 5 means the instruction is not available. Here this is one example is there. Here you can see, I think it is visible to you all. This is the instruction I1. These are clock cycles, 1 2 3 4 5 clock cycles are there. Instruction I1 is fetched, decoded, executed, and write back. Okay, so here the instruction is not available till this stage, till the like here, Okay, till at the end of the clock cycle, till this fifth clock cycle, second instruction is not available. The I2 instruction is not available. I2 instruction is not available. Okay, so because of this non-availability of the instruction, a delay occurs. Okay, because here if the instruction is not fetched, then it will affect to the next instructions also. Okay, so the same diagram, whatever here, it is represented in a function performed by the each processor stage in a successive clock cycles. See what happens here. See here, this fetch, the instruction is not available. So here it is fetching, second clock cycle it is not available. Okay, in the second clock cycle the first instruction is in the decoding stage. Okay, in the decoding stage, and second instruction it is fetching. Okay, but it is not available. Okay, here also it is fetching, but it is not available. So here it is supposed to take only one clock cycle, right? But it is taking the 3 clock cycles extra. So this particular 3 extra is there, no? So this is called as 3 idle period. We call it as idle period, idle periods or bubbles. Means खाली था वहाँ, कुछ काम नहीं है. Means it is fetching. There is no utilization of that fetch unit. It is called as bubbles. So in instruction hazard, you may get MCQ questions in the examination. In instruction hazard, if the instruction is not available and it creates a dash stall, so that is called as idle period or bubbles. It is called as idle periods or bubbles. Okay, see here, the whatever this diagram is there, no, it is represented in this way. Yeah, horizontally and here vertically. Fetch unit, decode, execute, write. Here clock cycles. Means here the utilization, like first clock cycle may first instruction is fetched. Second clock cycle, the second instruction is fetching, and the first instruction in the decoding stage. Third clock cycle again it is fetching the same. Second instruction को ही fetch कर रहा है, and decoding का कुछ use नहीं है. Decoding it is not doing because the next it is not fetching. Okay, so it is in the idle stage. A particular third clock cycle में ना, here we are not using any decoding. Okay, क्योंकि next instruction ही fetch नहीं हुआ है, so idle period it is. Then the first instruction is executed. Okay, so likewise all other stages also. Okay, this is called as idle period. Okay, this is called as idle period, or we can call it as a stall or bubbles. Okay, so in the next class we will continue that.